Hello viewers, welcome to my channel. Today we are going to deal with the introduction to statistics. If this is your first time of viewing, kindly consider subscribing to my channel. It will always notify you whenever I upload a new content. Now, when the word statistics is mentioned, the only thing that should come to your mind is what I'm going to write on the board now. So I'm saying in essence today that statistics can be seen as the proper way of collecting, documenting, analyzing, and interpretation of numerical data, which can vary from place to place, time to time, and person to person. Whenever you go to collect an information, you don't end it there by collecting the information. The information you've collected must be used for certain works, for analyzing to know the situation at hand, to know the next step at hand to take. Take for instance, if you come into a class and as a principal of the class, you want to sew a uniform for the students of your class, and you want to know the number of boys and the girls in the particular class so that you know the quantity of uniform to get for girls and that for the boys. Okay, you must go and collect information. What information are you collecting? You are collecting the total number of boys and total number of girls in the class. You don't end it there by collecting it. You have to analyze to know the mode, to know the gender that is higher than the other, so that you should know the quantity of uniform that should be bought for the boys and the girls. All these things are all statistics, collection of information. Okay, that is why I say you don't end it there by collecting the information. Sometimes you can document, you can analyze it, you can interpret it, you can use it to even predict future happenings. That's one of the importance and uses of statistics. And these statistics will always vary from place to place, time to time, and person to person. In fact, anything that deals with data collection is referred to as statistics. Okay, and having known the meaning of statistics, you also need to know the meaning of data. Data. Data is just an information, a piece of information. For example, now that time I went in a class to collect the number of boys to girls. What I'm collecting is an information, and that information is just data. So data is just a piece of information. Okay, we still have your raw data. Raw data is just information as well, but that information is new. It has not been worked on. You've not used it to do so many works. You've not analyzed it. You've not presented it, because we have data presentation. Okay, so it's just raw like that. Take for instance now, let me clean the board and tell you what I mean by raw data. So let's say in a particular class that you went into, and you find out that a test was given to the students in mathematics, and at the end of the day, these are the scores of 10 students. So you can see this information here. They are raw data because it has not been presented, it has not been analyzed to know the student strength, to know the score they are used to having, to know the problems that made them to have this particular score. Okay, so that is just raw data for you. You've not worked on it, you've not presented it, you've not analyzed it, you've not documented it. It is just like that, a raw data. Okay, we have frequency table. Now whenever you present a data or an information together with its frequency, the resulting table will give you what we call a frequency table. Take for instance now, let me put more scores here. Let's say 5, 4, 2, 1. Let me change this 8 and 7 into 4, into 3, then here into 2 again. Now these are raw data, these are information. I can choose to present this information in a table. In that table we shall have, so now look at this table here. These are the scores the students obtained. Maybe the test is over 5. Now, how many persons scored 0? Only one person. You write the frequency as 1 because one person scored 0. Then they scored 1. How many persons? 1, 2. 2 persons scored 1. They scored 2. How many? 1, 2, 3. 3 persons scored 2. They scored 3. Let's see, 1, 2, just 2. 2 persons scored 3. What of 4? 1, 2, 3, 4. 4 persons scored 4. What of 5? 1, 2, 3. So 3 persons scored 5. You can write the frequency in tally. The tally 1, 2 is like this. 3, 1, 2, 3. 2 is 1, 2. 4 is 1, 2, 3, 4. And 3 is 1, 2, 3. So this resulting table here is what we call a frequency table. Whenever you present an information, a raw data in form of a table here, where each score or each information is presented directly with its corresponding frequency, you know that the resulting table is a frequency table. Okay, we have grouped data. Data can be grouped. You can see here that the scores I'm having here are just very few scores, 1 to 5. Okay, what if the test is over 100? If the test is over 100 and the population of the students in the class are much, you will not see that cannot start from here and be writing 0, 1, 2, 3, 4, 5, 6, to 100. In fact, it's going to take me a full note to finish this, and in fact, it will look somehow very odd, and it cannot be very understandable by me looking at it. Therefore, when the data is much and the population is much as well, we can group it. Let's say you find out that a test was given out of 100. Instead of writing it scores 1, 2, 3, 4, 5, 6, 7, 8, 100, you're wasting your time. You can choose to group it. You can say people that scored, let's say, 1 to 10, 11 to 20, 21 to 30, 31 to 40, etc. Okay? Then you can now have their frequency. You have now grouped them into 1 to 10, 11 to 20 groups till 100. You see that it is better this time around. When the population is very large and the scores are much, you are free to group it this way. Such data is known as grouped data. Okay, we have ungrouped data, just like you can see here. Every information is written singly, no pairs, no merging together. That is ungrouped data for you. Then also we have the cumulative frequency. Just like we have frequency table, we still have cumulative frequency and cumulative frequency table. Cumulative frequency is just the sum of the frequencies line by line. Take for instance, now if I want to form a cumulative frequency table from this table, I can just make another column here and call this cumulative frequency. Okay, to form the cumulative frequency, look at what I will just do. The first information here, the first frequency is 1. To get the next, I will say 1 plus 2. This will give me 3. I will say 3 plus 3. This will give me 6. I will say 6 plus 2. This will give me 8. I will say 8 plus 4. This will give me 12. And if I say 12 plus 3, this will give me 15. These are the cumulative frequencies. You see how I'm summing the frequencies line by line. Okay. Now we have the class size, or the class width, the class interval, and the class boundary. You will understand this from grouped data. It is from grouped data that you can understand this very well. Class size. For example, now this is a class of scores. The first class is 1 to 10, 11 to 20, 11, 21 to 30, etc. The size of the class is how many terms am I bringing together? Okay, look at where am I? This is class size or class weight. You can see here that there are up to 10 data here that formed one class. You can call it 1, starting from, don't just say 10 minus 1 to get 9. It is wrong. Can't give you that. Rather, you say start counting from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You will see that the class size here is 10. So the class size here is 10. The groups you are putting together. If I use, let's say, 1 to 5, it means that the class size here is just 5. If I use 1 to 4, it means that the class size is 4. Okay, that is how to get class size. You can get class size when we get into the class boundary also, because it is from the class boundary that you can easily get the class size without much difficulty. Look at class interval. This is just the interval. Interval is just like the boundary. Where am I starting? Where am I ending? So this class is starting from 1 and ending at 10. This is starting from 11 and ending at 20. This is starting from 21 and ending at 30. These are the class interval, or you call it class limit. It can be called class limit. That's just the class interval for you. So 21 to 30, 31 to 40, 41 to 40, 41 to 50, etc. We give you the class interval. Now, what of class boundary? Now, to get the class boundary, many people are always saying that class boundary is just remove 0.5 here, add 0.5, remove 0.5, add 0.5. That is the trick they are using, even though it's correct, but that is not the standard. That is not the standard. Remember, in the class interval, this one here, all these ones here are the lower class interval. Here is the lower, while here is the upper. Then here is the upper class interval. Okay, so we have lower class interval, upper class interval. The same thing applies to class boundary. We have the upper class boundary and lower class boundary. So here is the lower class boundary, while here is upper class boundary. Now, to get the, I'll clean here. To get the lower class boundary, look at what you do. Just assume that there is a class before this particular class you're having here. Okay, and since we have 1 to 10, the next class here should start from what? Okay, the next class here should be, let's say, minus minus something, minus a positive negative value to 0, because this starts at 1, so the next one must begin from 0. So let's say minus 11 to 0, or minus 10 to 0, for instance. Okay, now there is a class here which ends at 0 before this particular class begins. Okay, now to get the lower class boundary, just say 0 plus 1, then divide by 2, and 0 plus 1 over 2 will give us 0.5. So the lower class boundary is 0.5. To get the upper class boundary, look at what you do. Okay, sum this number here, 10 plus 11, 10 plus 11 divided by 2. 10 plus 11 is just 21 all over 2, which is 10.5. So here is 10.5. If I want to get the lower class boundary here, I will add this and this also for the next class. I will just say 1 plus 20 will give us 21. If I divide 21 by 2, I will still get 10.5. If I want to get the upper class boundary, I will say 20 plus 21. Okay, it will give me 41. Dividing 41 by 2 will give me 20.5, and so on and so forth. But the trick students do, look at how students combat with this in examination to save time. They will just remove 0.5 from the lower class interval and add 0.5 to the upper class interval. They will just say 1 minus 0.5, 10 plus 0.5. 11 minus 0.5, 20 plus 0.5, you get this. Say 21 minus 0.5, it will still give you 20.5. 30 plus 0.5 is 30.5. That's just the trick. Remove 0.5 here, you get this. Add 0.5 here, you get this. This is how you get your lower class boundaries and the upper class boundaries. Okay, but that is not the ideal way. In case you are teaching someone tomorrow, this is how it is got, but this trick can still help us to get exact 10. Okay, now I'll come back again to this class size, where we use the class interval to get it. And so many people think that class size is just 10 minus 1, 20 minus 11. It is wrong. It's either you remove you start counting from 1 to 10, 1 inclusive to 10, you get 10, or directly upper class boundary minus lower class boundary of any class will give you just 10. So here the class size is just 10, or you can say 20 minus 10, or 11 minus 1, 21 minus 11, 30 minus 20, etc. That is how to get class size. In my next video on statistics, I'm going to be dealing with the measures of central tendencies. In order not to miss anything coming from this my channel, kindly subscribe and press the bell notification icon so that you'll be notified whenever I upload a new video. Thank you so much for your audience.